In this video, we're going to talk about how to find all the solutions to the trig equation cotangent theta is equal to 0. Now, whenever we're doing trig equations, I always try to relate it back to the unit circle because I think that's a great way to solve the problems, to get a starting point for our answers, especially when you're not given an interval where we'll have an infinite number of solutions, and so it's a great way to get the starting point. So looking at cotangent theta, you may know what cotangent theta is in terms of sine and cosine using your quotient identities. And if you do, that's great. If you don't, let me explain it to you. So using your quotient identities, cotangent theta is the same thing as cosine theta divided by sine theta. And so we want that to equal 0. And so we're interested in all the places on the unit circle where cosine theta divided by sine theta is equal to 0. But since it's on the unit circle, we can make this a little bit nicer. We know that on the unit circle that cosine theta is the x value and sine theta is the y value. So we want to know all the places where x over y is equal to 0. And in order for you to have a quotient equaling 0, the numerator has to be equal to 0. So really what we're interested in is we're interested in the places where the x value is equal to 0. So now let's go along the unit circle and let's circle everything between 0 and 2 pi where we have an x value equal to 0. And that's going to happen in two places. It's going to happen at pi over 2, or 90 degrees, and 3 pi over 2, or 270 degrees. And so those are going to be our two solutions to this problem. We're going to have theta is equal to pi over 2, and we're going to have theta is equal to 3 pi over 2. Now, for this particular problem, we can't stop here because we're not given a particular interval where we want our solutions. And so we need to take into account that there are really an infinite number of solutions. Every time that we add 2 pi to one of these answers, that's just going to take us all the way around the unit circle another time, and we're going to have, for that case, pi over 2 plus 2 pi, but it's going to be a coterminal angle, so we're still going to have the same x value, meaning that is still going to satisfy our original equation, cotangent theta is equal to 0. And then we could add another 2 pi to that if we wanted to, another complete rotation around the circle, and we could add 2 pi over and over and over again forever to get an infinite number of solutions. Or we could subtract 2 pi away forever to get an infinite number of solutions. And we can't only just do that with the pi over 2, we can do it with the 3 pi over 2 as well. And so the way to handle this problem and to be able to represent all of these solutions in a succinct manner, because obviously you can't write an infinite number of things, you'd be writing forever, is to say our starting point is pi over 2. It's kind of like our anchor point. And we know that we can add multiples of 2 pi. So we can add 2 pi multiplied by k, where k is going to be an element of the integers. And keep in mind, an integer is just like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, continues going in both directions forever. So it's all the positive, negative, whole numbers, and 0. And so you could imagine multiplying that by any number you wanted to that was a whole number, say -3, and that's the same thing as subtracting 2 pi 3 times. Or if k was equal to 5, that's the same thing as adding 2 pi 5 times. So you're always going to end up in the same spot, and therefore we're always going to have the same x value equaling 0, meaning we're always going to satisfy our original equation. So let's do the exact same thing to the 3 pi over 2, kind of our other anchor point. Again, you can add any multiple of 2 pi. It's going to be a k being an integer. So any integer we multiply by 2 pi is going to be a multiple of 2 pi that we can add or subtract away. And that's going to give us, again, a coterminal angle, which is still going to satisfy the original problem. And so there we are. Those are our solutions. So in general, that's the strategy you're going to take whenever you're looking for all of the solutions. To represent the infinite number of solutions, what you're going to do is you're going to take your anchor points, or the original points that you find on the unit circle, and you're going to add 2 pi times k, where k is an integer. And sometimes people use n instead of k, and so for instance if you're working on Alex and it says n instead of k, then just know that represents the same thing. It's just a placeholder.